Hello everyone. In today's extensive video, we'll be discussing the top 10 shocking facts about the Sun, our nearest star and the principal source of light and warmth for life on Earth. While many people think of the Sun as just a bright ball in the sky, in reality it's far more complex and fascinating, with properties that can truly surprise even seasoned astronomers. Before we delve into each point, please hit the like button, leave a comment telling us which fact surprises you the most. Subscribe to our channel so you don't miss upcoming content about space and science. And check out our merch below. Every purchase helps us produce more in-depth videos. Let's jump into the 10 incredible facts about the Sun. The Sun contains over 99% of the solar system's mass, starting off with a commonly cited statistic that many people don't fully appreciate. The Sun holds over 99% of all mass in the solar system. All the planets, including massive Jupiter and Saturn, together with their moons, asteroids, comets, and dust, compose only a tiny fraction of a percent. This tremendous difference in mass is precisely why the Sun dominates gravitationally. It dictates the orbits of planets and controls the overall structure of our cosmic neighborhood. Even if you combined every planet into one giant sphere, the Sun would still be thousands of times more massive. Why is this so shocking? Because from a human perspective, Earth can feel quite large. Yet it's merely a speck compared to the Sun. Essentially, the solar system is heavily sun-centric, far more than most might realize. It doesn't burn like fire. It's powered by nuclear fusion. We often say the Sun burns or is on fire, but from a chemical standpoint, there is no oxygen-based combustion happening as you would have with wood or gasoline. Rather, the Sun is a huge ball of plasma, fueled by thermonuclear reactions, primarily hydrogen fusing into helium in its core. The core temperatures exceed 15 million degrees C, and the enormous pressures allow protons to fuse through what's called the proton-proton chain, releasing vast amounts of energy. Why is this surprising? Because everyday language leads us to imagine flames. But actual burning requires oxygen, which is absent in the Sun's core. Instead, the Sun is best described as a massive nuclear reactor performing fusion. Differential rotation, different speeds at the equator and poles. On Earth, a solid body, we talk about one rotation in about 24 hours. However, the Sun is not solid. It's made of plasma and gas, so different parts rotate at different speeds. At the equator, the Sun completes a rotation in roughly 25 Earth days, whereas near the poles it can take about 35 days. This phenomenon is known as differential rotation. Why is that important? Differential rotation twists the Sun's magnetic field, leading to the formation of sunspots, solar flares, and other dynamic phenomena on the solar surface. It shows how far the Sun's behavior is from a calm, unified spin. The outer atmosphere, corona, is hotter than the surface. The photosphere, i.e. the visible surface of the Sun, has a temperature of about 5,500 degrees. In contrast, the corona, the Sun's thin, outer atmospheric layer, can exceed 1 million degrees Celsius. Intuitively, you'd expect it to get cooler the farther from the core you go, so this is a major puzzle. Astronomers suspect certain magnetic processes or wave phenomena, like Alfvén waves, deposit energy in the corona. The precise mechanism remains a challenging topic in solar physics. Why is this shocking? Because it contradicts the everyday notion that further from a heat source means cooler. On the Sun, intangible yet powerful magnetic and wave processes superheat that outer layer beyond all expectation. Solar wind affects Earth's magnetosphere and can trigger auroras. The solar wind, a constant flow of charged particles, mainly electrons and protons, streams outward from the Sun into interplanetary space. When stronger bursts of these particles reach Earth, they can disturb our magnetosphere. Large solar flares or coronal mass ejections, CMEs, can cause geomagnetic storms, intensifying auroras, northern and southern lights, and sometimes knocking out satellites or electrical infrastructure. Why does it matter? Because a sufficiently powerful solar storm, like the famed 1859 Carrington event, could disrupt modern technologies. Our communications networks, GPS and power grids might sustain severe damage, reminding us that the Sun's activity profoundly influences life on Earth. The Sun is about 4.6 billion years old, and not old in stellar terms. Estimated to be around 4.6 billion years old, The Sun is roughly halfway through its stable main sequence lifetime, meaning it can continue fusing hydrogen into helium for another 4 to 5 billion years. After that, it will enter a red giant phase, potentially engulfing the orbits of Mercury and Venus, possibly even Earth. Why is this surprising? Though 4.6 billion years is unimaginably long compared to human history, in stellar terms, it's just a star in its midlife. It underscores the cosmic timescales that overshadow any civilization. For us, billions of years might as well be eternity, yet for the universe, it's not unusual. One galactic year equals 230 million Earth years. While the Sun is the center of our solar system, it orbits the center of the Milky Way galaxy. Completing one orbit around the galactic core, often called a galactic year, takes approximately 230 million Earth years. That means the solar system has only done a handful of such orbits since the age of dinosaurs. Why is that shocking? It shows how immense cosmic scales are. We measure years in 365 days. But for the Sun's journey around the galaxy, we have to think in terms of hundreds of millions of years. The Sun produces billions of neutrinos that pass through us, constantly. Inside the Sun's core, nuclear fusion also creates huge numbers of neutrinos, extremely light particles that barely interact with matter. Trillions of them stream through your body every second without you noticing. Scientists discovered them via large underground detectors, e.g. Super Kamiokande, confirming that the proton-proton fusion cycle in the solar interior indeed emits neutrinos. Why is this surprising? Because neutrinos are invisible, ghostly, and carry direct information from the solar core, crossing the cosmic void at nearly the speed of light. It's remarkable that an entire wind of neutrinos is constantly passing right through us. The surface is dynamic, full of sunspots and eruptions. If someone envisions a calm, uniform solar disk, that's far from reality. Sunspots, darker regions with intense magnetic fields and slightly cooler temperatures, pepper the photosphere. Their frequency follows an 11-year cycle. In tandem with these, the Sun experiences flares and coronal mass ejections that violently hurl plasma into space. That swirl of magnetism and plasma is crucial to the Sun's temperament. Why is this shocking? We might think of the Sun as stable and unchanging day to day, but in truth it's roiling with convection, swirling magnetic loops, and giant prominences. The dynamic solar surface is extremely active and far from serene. It sustains life, yet will one day destroy Earth finally. While it may sound obvious, it's quite dramatic. Without the Sun, there would be no life as we know it. If it suddenly vanished, Earth would cool within days, photosynthesis would cease, and ecosystems would collapse. But the Sun isn't immortal in its current state. Billions of years from now, it will swell into a red giant, likely swallowing or scorching Earth's orbit. Why is this shocking? Because the same star that now nurtures life could, in the distant future, make our planet uninhabitable. The timescale is huge, billions of years, yet it reminds us that even stable stars transform eventually. These are 10 shocking facts about the Sun, ranging from its overwhelming mass dominance and nuclear fusion processes to its puzzling million-degree corona and future as a red giant. The Sun is the literal center of our daily existence, and yet it harbors complexities, like differential rotation, solar windstorms, and neutrino flux, that are truly mind-boggling. We rely on its stable, steady emission of energy for life, but we also know that intense solar activity can disrupt our technology and that, in billions of years, our comforting star could engulf the Earth. We hope these facts gave you a fresh perspective on how awesome and surprising our star can be. If you enjoyed this top 10 shocking facts about the Sun, please click like. Tell us in the comments which fact blew your mind the most. Subscribe to our channel for more cosmos-related content, and take a look at our merch. Every bit of support helps us bring more in-depth videos. Thank you for watching, and don't forget to appreciate our life-giving, yet potentially destructive, cosmic reactor, the Sun.